Today we're going to build a full invoice parsing / automation system. The idea is we're going to upload invoices as PDFs, as images to our application. Then automatically we're going to extract all the relevant information from the invoice. And in addition to that, we're also going to embed it in vector space to allow for semantic search. So we can just provide a fuzzy search query like where is the invoice that was with company XYZ about roughly $200. And we're going to be able to find the invoice by doing a vector similarity search. We're going to do all of this without actually needing any machine learning frameworks because we're going to use a database called RavenDB, which has all these AI features already built in the database. So all this functionality will be in there, and we're going to build a Flask application around it in order to use this database. This is going to be a super interesting project, so if you like this video, let me know by hitting a like button and subscribing, and now let us get right into it. Now, before we get started with the actual tutorial here, I want to show you what we're going to end up with as a motivational preview up front. We're going to build an invoice parsing and invoice automation system. The idea is we can just drag and drop or upload invoices here. We're going to do automatic document extraction. There's also going to be an embedding into vector space, so we can then do a simple semantic search, like give me the invoice where I bought a keyboard, for example. And I want to show you how this works. We can just open up an invoice PDF here, upload and parse. Open up a Costco PNG. So this is an image of a Costco invoice. This is what the two files look like. We have invoice like this here, a structured PDF invoice, or just an image of a Costco invoice. That is what we're feeding into the system. And after a while, without us having to do anything, these untitled invoices here are going to be parsed. So after refreshing, we can see one of the invoices is parsed, the other one is still loading. And we can get the total price here. We can get the individual items from that invoice, unit price and quantity and amount, and then again, total amount. And at some point, both invoices are going to be parsed. So here we can see that we also have the other invoice, and then I can do semantic search. For example, I can look for Costco. This is going to show me this one. Or I can look for something like I bought some keyboard stuff. And in this case, both are a match for whatever reason. But maybe if I go with mechanical keyboard, then I only get this one because a mechanical keyboard was bought here. So that is what we're going to build today. And just a heads up, we're going to build the entire functionality from scratch by hand. We're going to learn how this is done. The only thing we're going to vibe code is the UI. I'm not going to design this with you guys in this video. So we're going to build a minimal HTML version, and that well-designed version then is going to be vibe coded with Claude Code. But that's just going to be 1 minute of the tutorial. The rest is going to be educational, backend, and database stuff. All right, so we're going to build a full invoice automation / invoice parsing system in Python today. And as I already mentioned, the special thing about this tutorial today is that all the functionality, all the generative AI functionality will be done directly in the database. We're going to use the database called RavenDB in this video today. So the document extraction from PDF, from image to a structured output, and also the embedding with the similarity search, semantic search will be done inside of the database directly. We're only going to use Python, so to say, as a web application, as a UI around it. We're going to build a simple Flask application in order to use the functionality, but everything will be done directly in the database. Now, for the sake of transparency, I need to mention that RavenDB is sponsoring this video today, so this is a paid collaboration, but of course, I'm going to show you everything unfiltered. I'm going to show you how it works, and I'm going to give you my opinion as we go. In terms of pricing, you don't have to pay anything in order to do what we do in this video today. You can go to the pricing tab on-prem. Here you can see the paid plans, but down below you can also see that there are 2 free licenses, the developer license, which we're going to use in this video today, and the community license, which is eligible for commercial use. We're not going to use this one today. We're going to focus on this one because it allows us to use the AI features. And these are basically the paid tiers that you can use if you want to use this professionally in your applications. Now, I don't want to ramble any longer. Let us get into building. The first thing we need to do, of course, is to get RavenDB onto our system. You can do that by using the installer for your respective operating system, or by using Docker. So you can go here to get started for free. You can get the on-prem instance, and here you can choose your operating system or Docker, and it will provide you with the instructions. I'm just going to do my own Docker Compose setup here, so you can follow this download guide if you want to, or you can just follow exactly what I do. I'm going to open up my terminal, navigate to my tutorial directory, and in here I'm going to create a Docker Compose file. By the way, I'm not going to cover the Docker setup here, just get Docker onto your system and Docker Compose. You can also use, as I said, the installer, or if you want to learn about Docker, I also have a crash course on it, so you can watch that. But here I'm going to assume that you can just run Docker Compose. So we're going to create a Docker Compose YAML file, and we're going to define a service for RavenDB, which is going to use the image RavenDB latest. We do need to map some ports. So we need, on the one hand, the 8080 port for RavenDB for the web interface. And we also want to have 3 and then 4 times the 8, which is going to be the TCP port. So we do this mapping here. We also want to have a volume. I'm going to call this RavenDB data. And that is going to be /opt/ravendb/server/raven data. Then we also want to have 2 environment variables, and these are going to be for skipping the setup wizard and also for allowing insecure access on localhost. So I'm going to say here Raven in all caps and then _setup_modes. That is going to be none, so we don't use the configuration wizard. And then Raven security unsecured access allowed only for private network. Of course, these are not production settings. These are just for playing around with it locally. And then I'm going to say volumes, of course. We need to define RavenDB data. That is my Docker Compose setup. So now I'm going to run Docker Compose up, and this is going to run RavenDB now on localhost port 8080. So I can type into my browser 127.0.0.1 or just localhost and then 8080. This is going to, after I reload this properly, going to redirect me to RavenDB here. And this is what it looks like by default. So it doesn't have anything. We don't have any databases. We are using the free license, which is the first thing I want to change here so we can directly start using also the advanced AI features. So we can go down here to About, and you will see here it says no license AGPL version 3. So we have certain restrictions. We cannot use the AI features. So what you want to do is you want to get the free license, the developer license. For this, again, we just go to pricing. We go to on-prem. As I showed you, you scroll down here to the developer license, get your license. All you have to do is you have to fill out this form. You will get an email with the license, and you have to then copy paste it here into register license. So this is the structure. You will get an email with a JSON type object here that has an ID, name, and everything. You just paste it here and you say submit. So in my case, I also do that, hopefully censored, and I just submit this. And there you go. Your license was successfully registered. Thank you for choosing RavenDB. And here it says developer license not for production use. This is just for playing around. And then you can choose to use the community edition or a paid tier. Now we have access to all the features relevant to this tutorial. And we can start by setting up our Invoice database. So I'm going to go here to databases, new database, and I'm going to call this Invoice DB like that. I'm going to go next. Here we have replication and sharding. There are aspects to RavenDB which are very interesting, like you can run multiple clusters. You have ACID, NoSQL database, NoSQL database. We're not going to touch on all this because we're going to focus on the integrated Gen AI features, but there's interesting stuff to explore here as well. For now, we're just going to say next. We're going to say finish, and now we have this Invoice database. And to create the collection invoice or invoices, we just have to submit a sample object. So I'm going to go here, I'm going to create a new document. This is a JSON object essentially, and I'm going to provide some of the data that I'm interested in. So an invoice, what do I want to extract from an invoice? I want to extract an invoice number, and an invoice number by default here for this empty object is going to be null. And now we're going to repeat this. I'm going to say here seller name. Well, let's call this seller party name. That is also going to be null. Then I can copy this. I can say buyer party name is what I want to extract as well. Null. Then invoice total null. And I also want to have a list of invoice positions. So invoice positions means multiple items. This is going to be an empty list. And then important, we need to specify that this is a certain collection. So we need to specify the metadata at metadata, and that is going to point to a dictionary. And here we want to say at collection, that is going to be invoices. So this is now a sample object. I can call this invoice 1 or something here. I can save this, and now I have an invoice object in this document database, in this NoSQL database. Now what we can also do is we can add attachments. So I can say here, add attachment, then I can go to my tutorial directory and choose to upload an image of an invoice or a PDF document, whatever. Now these two are just fake invoices that I created. One is generated with a Python script. Another one is just a ChatGPT generated image of a Costco invoice, which is not real. But basically I can just choose to upload this, and now this belongs to this document. So this document has the information, the fields that we have here, but also a binary attachment. Now, for now, I'm going to delete this because I want to show you the AI feature of document extraction here. And for this, we need to take a couple of steps. The first thing is we need to connect to some LLM provider, to some AI provider that we can use. For this, we're going to go to the left here to AI Hub, to AI connection strings, and I'm going to connect to the OpenAI API by saying add new. Then I can call this one here OpenAI chat. And the reason I call this chat is because we can choose between two model types, chat and embeddings. We're going to use both, but for now, for the extraction, I want to use chat. And then I can select a connector here. I'm going to go with OpenAI. And for authentication, of course, we need to provide an API key. So you can just go to your OpenAI API, create a new secret key, give it a name. I'm going to call this RavenDB tutorial. Then you can click create secret key. This is going to show the key. You want to copy it and you want to paste it there. I'm not going to show this part on screen. So now I have it copied in my clipboard. I can just paste it here, and now I have the API key provided. I can then select a model for the document extraction. I'm going to go with GPT-5.5. I think this is the most capable model right now. And I can just test the connection to see if everything works. And once it works, I can save the connection string. There you go, successfully connected, save. And now we have OpenAI chat as a model, as a connection that we can use. We use this connection in an AI task. So I can go here to AI tasks, and I can say add AI task to add this document extraction task. And this is going to be a Gen AI task, not an embeddings generation task. So I'm going to click on this button. I'm going to call this one here extract invoice, and the identifier is going to be extract invoice. It's going to be enabled by default. We're going to use the connection string OpenAI chat. So we're going to use the OpenAI model that we just set up. I can again test the connection if I want to. And once I get the confirmation, I can click on next. And now it asks me the source collection. So what am I actually looking at? I want to be looking at my invoices. This is important. You want to create a sample object first to create a collection so we can select it here. Otherwise, we cannot select something that doesn't exist yet. So the collection needs to exist already. We can just add a document the way we did it. This creates the collection invoices. And now we can generate the context using a script. So this is basically just JavaScript. I'm going to say AI gen context. We provide here a dictionary with doc ID being ID of this particular document. We're going to say then with PDF, and I'm going to later on change this context generation script to allow for different file types, images and everything, and to also not focus on file names. But I want to show you an MVP version first so you can see how this works. So we're going to say here with PDF, actually with lowercase d and f, and we're going to load attachment, and this attachment will focus on a specific file name, again, to keep it simple, invoice.pdf. And then a semicolon. Again, later on, we're not going to focus on the file name. We're going to allow different formats. But for now, that is going to be what we do. We look at the attachments. We say we're looking for invoice PDF. We're loading this as PDF into the context. Then we can click on next and proceed with the prompting. And here we can define the prompt, the instruction to the model that tells it what to do the actual document extraction. And then we also define a response schema. We can do that either by providing a sample response object or by providing the JSON schema itself. I'm going to go with the sample response object. And for the prompt, I'm going to use the following: extract the invoice data from the attached PDF, the invoice number, the seller name, buyer name, the invoice total, and every line item with its description, quantity, and unit price. That is the instruction. This is what we want from the model. And now we need to teach it what to respond with, what the structure of the response should look like. So I'm going to provide the following schema, basically what we did before, our basic object here that we defined with null, 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 now filled with values, invoice number, or actually invoice number with you here, ABC 12345, seller party name, buyer party name, invoice total, invoice positions, and then here we have dictionaries of items that can also be multiple. So we have a list here of dictionaries, item, quantity, unit price. That is basically our sample response object. Based on that, it should fill up the structured output object as well. So after that, the final thing that we need to do is we need to take the output and apply to the actual document, to the actual object that we're working with. So we're going to say here, this dot invoice underscore number is equal to whatever the invoice number is in the output. So this invoice number is dollar output and then invoice number like this. And then we can repeat that basically for all the other fields. So I'm going to copy this. I'm going to say here, seller party name is equal to output seller party name. And then we also do that for buyer party name, invoice total, invoice positions. That's the basic idea. This is our update script. It just takes the output and applies it to the document. Then once we're done with that, we can say next, we can save, and now our task is enabled. What does this mean exactly? It means that when I go to a document now and attach a file called invoice PDF, this is going to run automatically without me having to do anything, and it's going to fill up this document with the extracted information. So we can go to documents, we can go to invoice 1, I can say add attachment, I can go with my invoice PDF file here, and now we're going to have to wait. This is going to take some time, but I don't have to do anything else. I don't have to trigger something. I don't have to go to the task or anything. I can just keep using my application, my database, whatever. I can play around, and after some time, this is going to be filled up with data. As you can see, we have the seller party name, the buyer party name, we have the invoice number, we have positions. And by the way, this is what the invoice looks like. This is what we're actually extracting here. We have a bunch of positions and a total of 1,107. And in my invoice here, you can see that this is also what we get as a result. And if the results don't fit, you can always change the prompt. You can always change the model, the response model. But that is basically the idea. This is how we can do document extraction easily in RavenDB without having to use any framework in Python. We didn't even touch Python yet. We're just setting up the database. Now what we're going to do is we're going to extend the functionality to not only work with PDF documents, but also with images, and also so it doesn't have to focus on the file name. So for that, we're going to go back to AI Hub. We're going to go to AI task, and we're going to edit our task. We're going to go back to the context, which is this here, and we're going to change this. To not waste any time, I'm going to copy paste this, but the logic is quite simple. Essentially, we're just getting the attachments. We're saying if there is an attachment, get the first attachment because we're only going to support a single file here. And we're going to say if the file exists, we're getting it, we're getting the content type, and then we're just loading it as with PDF, with PNG, with JPEG, whatever, depending on what file type it has. That is the only thing that we're doing here. We're getting the first attachment, not a specific name. And by doing that now, I should be able to go and create a new object. For this, I'm going to go create a new document. Let's call this invoice 2. I'm going to paste here the default template again. I'm just going to save this. And now I'm going to add an attachment. This time it's going to be my Costco PNG. By the way, this is what it looks like. This is a ChatGPT generated or GPT image generated Costco invoice. It's not real. It's completely artificial, but the data is there. It can be extracted. I added this as an attachment. I can then just wait a little bit, and after a while, my data model here will be filled up again with the information from the invoice. So now there you go. We have a bunch of positions here. We have the invoice total. This is in cents, I think. Yeah, this is basically all in cents, and it looks roughly correct. Now, this is all the functionality, all the AI functionality for the document extraction. What we're going to do next is we're going to also add automatic embedding. So we have the information from the invoice embedded in vector space, so we can later on do semantic search. And then once this is implemented, once this is set up, we're going to go into Python, or we're going to create a Python file, which is going to be a Flask application that is going to interact with this database, and we can see that all the functionality can stay within RavenDB. Now for the embedding, we need to create a separate connection string, so we're going to go back to AI Hub, to AI connection strings, add new, we're going to go with OpenAI embedding, we're going to go with text embeddings, select connector, OpenAI, and the model is going to be after we chose the API key again. So paste the same API key up here. And then we can scroll down to text embedding large, for example, or 3 large. We can test the connection again, successfully connected, save connection string. And then we can create a new AI task. So I can say here, add AI task, embeddings generation. I can call this here embed, or just embed is fine. Embed is the identifier, enabled by default. Connection string is going to be OpenAI embedding. Collection here is invoices, and then I can use a script for the embedding source. Now this here I'm also going to copy paste, and you're going to find all of this on my GitHub, so you don't have to type it off the screen if you don't want to. But basically I can go Shift F11 to go full screen mode. Basically what we have here is we say embeddings generate, and we provide just the text for the embedding, and this is just a crafted string. Seller is this seller party name, buyer is this buyer party name, total is this invoice total, and for the items we need to map, so we need to actually create a string representation from the list. So we say this invoice positions or empty list, and then we map this to the string that is basically just the item name, the quantity, and the price. So this is just turning this into a text representation, and then we say embeddings generate. That is the basic idea. This is our logic here. And what I also want to do is I want to apply this, I want to reapply this onto existing data. So first of all, we're going to save here, and then I'm going to go here into embed, and I'm going to say regenerate embeddings for all documents. I'm going to click on this here. I'm going to toggle it. I'm going to save, and as a result of that, that is going to be applied to the already existing invoices. So they're going to be embedded. You can see here embeddings invoice 1, invoice 2. This is happening automatically. And before we go now finally into the coding, I want to show you how to query that. This is basically what we're also going to do in Python. I'm going to say here, the query is from invoices where vector search embedding text AI task embed. This is our task that we created. And then I can provide some query, like I bought some keyboard stuff, and then find the invoice where this matches with a threshold of 0.7. Maybe we have to adjust that. If I run this, we get here though the invoice 1, which contains invoice positions, mechanical keyboard. Now, if I lower this enough, I'm going to get everything. So if I say 0.1, I'm also going to get the other one, which contains Kirkland stuff. So we can go maybe back and say I bought some Kirkland stuff and set this back to 0.7. Maybe we will get the other one then. There you go, we get the Costco one. And I can of course also provide stuff like Costco directly, which is going to be even easier. Then it's going to find the invoice that I'm looking for. That is now the functionality, everything happening in RavenDB, and now we're going to build a simple Flask application around it. So now we're going to build the Flask web application. Important, you want to keep RavenDB running in the background. This is the database that we're connecting to, so don't close this. I'm just going to move this to my second screen here. And now I'm going to open up my terminal, navigate to my tutorial directory, and in here I'm going to create a directory called code, which is going to be for our Flask application. Now, we're going to develop this Flask application in 2 iterations. The first one is going to be super minimal, no JavaScript, no CSS, just a basic upload and also a basic listing of the invoices with a semantic search and no user interface whatsoever except for the basic HTML. In the second iteration, we're then going to use coding agents to vibe code a nice UI. We're not going to change anything about functionality. So the first part is going to be manual coding so we understand what's happening. The second part is just enhancing it to make it look interesting. Now, what you want to do is you want to install Flask on your system. So pip or pip3 install Flask and also RavenDB, the Python package RavenDB. Now, in my case, I'm not going to use pip or pip3 install. I'm going to use UV, the Rust-based Python package manager. So UV init, UV add Flask, and RavenDB. This just means I'm using now an isolated environment, a virtual environment, and I'm also using a faster package manager. That is the only difference. Except for that, you can just do pip or pip3 install. Then we're going to create a file called app.py for our Flask application. And we're going to start by saying from RavenDB import document store. This is going to be in order to connect to our database. And from Flask, I'm also going to import the usual stuff, Flask, request, then also render template, redirects, and URL4. This is what we're going to need today. We're then going to say that the store is equal to document store. We are going to point URLs. This can be a collection because we can have multiple nodes of RavenDB running, but we're only going to use http://localhost port 8080. And the database is going to be our invoice DB. Then we're going to say store.initialize and we're going to say app is equal to Flask or Flask application underscore underscore name underscore underscore. That is the setup. Now we do need to create a class for our model, for our invoice. So I'm going to say here class invoice def init. It's going to take self, obviously, then the invoice number, which is going to default to none. Then the seller party name, which is going to default to none. The buyer party name, which is going to default to none. The invoice total, that is going to be equal to none. The invoice positions that are going to be equal to none. And the embedding text that is going to be equal to none. So that is going to be our init method. And then, of course, we need to do self dot invoice number is equal to invoice number. Self dot seller party name is equal to seller party name. And then we do that for all the different ones, like this essentially. Now, once we have that, we're going to define our first endpoint. App route is going to be equal, or app route is going to be the slash route. That's going to be our index function here. And basically what we want to do here is we want to get a query, optional query, so the user can provide a semantic search query or not. And depending on that, we're either going to filter or not. So I'm going to say here query is equal to request arguments dot get, and we're going to look for a queue. If there is no queue, we're just going to return an empty list. We're going to strip the result here to get it clean. And then we're just going to say open a session. So open store or store.open session as session. And depending on whether we have a query or not, we're going to get either everything or a filtered result. So if we have a query, we're going to do something in a second here. Otherwise, we're just going to get everything. So I'm going to say here invoices is equal to list. And now we need to do a query with the session. So session advanced and then raw underscore query is going to allow us to use the query language of RavenDB. And here I'm just going to say from invoices like this in quotation marks. And basically the query here is going to be similar, just that we continue. We're going to also add filtering criteria. We're going to say where vector.search, and here embedding text. This is basically the same thing that we did before. Embedding text, and then our AI task, embed a placeholder, which is going to be $Q. We need to fill that later on. And then 0.7, which is our threshold. And of course, this can be adjusted if you want to. You can make it more or less sensitive. But that is basically the raw query. Now we need to say .add underscore parameter to fill the value for Q with the query. And that is basically what we're doing here. So we're saying, give me all the invoices where the search, where we can embed the text, and this similarity is at least 0.7. Given that query. So we're embedding the query and we're also looking at the embedding of the document. And then we just see if the match is strong enough given the query. And then we return the invoices where it is strong enough. And then basically we can just say return render template. I'm going to render the template index.html. And I'm going to say invoices is equal to invoices. And also query is equal to query if we want that, so that we can display what the query was. Then the second endpoint, and then we're actually done here in the Flask part. The second endpoint is going to be /upload. That is going to only take post requests. So methods is equal to post. And here we're just going to upload a new file. So I'm going to say upload, and we're going to say file is equal to request.files with the name invoice. We need to provide the proper name in the HTML. I'm going to open a session again. So store open session as session. And then basically we say invoice is invoice. We create a new empty object, session store invoice. And then we can say session dot advanced dot attachments dot store. And we can now attach to the stored invoice our PDF document. So we can say to the invoice object, we want to attach the file with the file name here. So file name, then file read is going to be the bytes that we attach, and file.mime type is going to be the file type. Finally, we say session save changes. And in the end, we want to redirect to index. So return redirect URL for index. That is the magic. Finally, we just have if name is main, our entry point, that's going to be app run debug equals true. I hope I didn't forget anything or didn't make any mistakes. Usually I do. Then we're going to fix them. But the next thing we want to do is we want to create a directory called templates. And in this directory templates, we're going to create index.html, not HMTL, but HTML. And I'm going to use a snippet here, HTML5, to just get the basic HTML5 blueprint snippet here. I'm going to say Raven DB invoice parser. And in the body now, we need three different things. We need a form for uploading a file, we need a form for searching, and we need the list of the results. So I'm going to say here form, first of all, action is going to be /upload. Method, as we discussed, is going to be post. And then we also need enc type is going to be multi-part form data. We're going to have input type file. The file name is going to be invoice, because that's what we're reacting to in Flask. And then we need button type submit, and we're going to say upload. Second form is going to be the search form. The action is going to be /, and the method is going to be get, because we're using URL parameters for the query. We're not using a post payload. And then we can say input type text. That is going to be the query, so that's going to be Q. And we want to have the value. If there is a query, we want to display the query. And otherwise, we want to show a placeholder semantic search. And then also here, button type submit search. Finally, we want to have the results. This is going to be an unordered list, and the unordered list is going to be using a Jinja for loop for invoice in invoices. We're going to iterate over them. We're going to say end for, and then we're going to have the individual list items like this. And in here, we're just going to say then that I want to have the invoice number, then a pipe symbol, and then in here also invoice seller party name, and then buyer party name as well. So that is just a simple for loop showing everything. Now we can save this. If I didn't make any mistakes, this should work. Let's see. UV run app py. Okay, it says, did you forget a comma? Let's see what the problem is here. Yeah, of course, it needs to be add parameter in parentheses here, add parameter Q query like this. And let me see. Then we need to close this off as well. There you go. I think that was the mistake. Now we can open this, and this is what it looks like. It shows us our two invoices here. If I do a semantic search with I bought some keyboard stuff, then I will hopefully only get one of them. If I do Costco, I'm also hopefully only going to get the other one. That works. And now let's see if I can add an additional Costco PNG invoice here. Upload. None, none, none. This looks good because that means that it's currently being processed. I will have to wait some time for this to work. I can also simultaneously try to upload another one of those. And once everything triggered, we can also take a look at the Raven DB dashboard. There we can see what's happening in real time. You can see we have the invoices here, and after a while, they should be filled with data. And there you go. We have the first one already, and the second one is also filled now. So that works. Now what we're going to do is we're going to make this look better, but we're not going to do this ourselves because I hate CSS and JavaScript. We're going to use Claude Code. I'm going to go and say Claude open here, and I will say make this Flask app look way better, more modern, interactive, and nice. Functionality can stay as is, but make it look professional. That's important because I want to, first of all, have something to show you guys. Also as a preview, I'm going to show you the final result so it looks interesting. No one wants to see a tutorial on how to build this. But actually, that's what we're building. That is the thing that we end up with. The only thing we're adding now is CSS and JavaScript. Okay, so now after a bit of prompting, we can see that in our Python code, almost nothing changed. The only thing it added here is a Jinja filter. So this is literally just formatting of text, only design stuff. Everything else stayed the same, so no new functionality. Everything else is in HTML, CSS, JavaScript, and this is now what our, of course, when I have to start it, UV run app PY. This is now what the application looks like. We have this full system, this full invoice parsing system. I have my invoices here. I can uncollapse them to show all the individual items with quantity, unit, price, amount. I can also search for Costco, for example. Search, there you go. I only get these two. I can upload a new invoice here, upload and parse. By default here, I get untitled invoice because we don't have anything yet. But when I reload after a while, I also get everything here as well. So this is how you can build a fully professional invoice automation, invoice parsing system in Python, where everything is happening in the database. Python was just used as an interaction user interface. Everything happened in RavenDB. So make sure to check them out. The link is in the description down below. So that's it for this video today. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, don't forget to check out RavenDB, the sponsor of this video today. The link is in the description down below. It's a NoSQL database that supports the ACID principle. You have built-in AI features, very interesting. Check it out. You support the channel by doing that. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you for watching. See you in the next video and bye.